This is a review for your 4-6 weeks test. Your 4-6 weeks test will be 20 questions that are multiple choice. You will need a pencil. Some of the topics that are going to be included are simplifying polynomial expressions whenever you're adding or subtracting polynomials, multiplying polynomials, that's whenever you're going to have to use FOIL, so x plus 2, x minus 3, that kind of stuff. Synthetic or long division, which will be covered on this page. Factoring polynomials, simplifying radicals using exponent rules, graphing polynomial functions. You can use your calculator to graph them. Transformations of polynomials. Most of the time you can use your calculator. Sometimes you'll have to know your different transformation rules. Simplifying fractions using exponent rules that we've been covering the last couple of days. Polynomial regression with a calculator. This is whenever you go to Stat Edit, type your information in, Stat Calc, and then you do a one of the regressions. Suggested ideas for preparing for your 6 weeks test. So looking at this this note section probably isn't going to be enough of a review. You're also going to want to look back at your notes that are taken this 6 weeks over these kind of topics. You might want to watch your video reviews for your previous test. Make sure that you've completed all assignments for this 6 weeks. Retake any test for which you have a grade below 70 or 60. Remember, you can retake anything below the 70. Sometimes kids don't see that as worth enough points. If it's below a 60, you definitely need to come in and retake that. Remember, you can come in any morning at 7:30 or any day during PASS. I'm happy to go over your test and then let you take a retest. So some sample questions are below. It is not a sampling of all questions, okay? So there will be questions similar to this. They aren't exactly the same, and there will also be other things that are not listed here. Which expression is simplified representation of the quotient for the division? Okay, so you have a 2x minus 3, so you're going to have to do long division right here. So you're going to have your 2x minus 3 underneath, and then your 4x cubed minus 12x squared plus 33x minus 39. And you're looking, okay, 2x times what gives me 4x cubed? Well, 2 times 2 gives me 4x. And then I need to go from an x to an x cubed, so I'm going to multiply that by x squared. So 2x squared times 2x is 4x cubed. 2x squared times negative 3 is a negative 6x squared. Then remember, at this point you are subtracting, so you can change your two signs, combine these down, so you'll have negative 6x squared, and then you're bringing down your next number, so plus 33x. So 2x times what gives us negative 6x squared? Well, that's going to be a negative, because I need to change sign, and then 3 gives me the correct coefficient, and an x gives me a x times x gives me x squared. So this is negative 6x squared. Negative 3x times negative 3 is a positive 9x. However, I am subtracting, so that's going to change my signs right here. So then 33 minus 9 is 24x. Bring down my negative 39. So 2x times 12 is 24x. So that gives me 24x. 12 times negative 3 is a negative 36. However, I am subtracting, so that's going to change to plus. Or sorry, that's going to change this to a minus, that to a plus, and I get negative 3. So minus 3 over 2x minus 3, which is J. Number 2, which a polynomial function of degree 3 is shown below? Which of the following best represents the complete linear factorization of the function? Okay, so you're wanting to factor this. Looking at factors, okay, so we know that any whole number, this won't factor with grouping. And so I know that any factors I have are going to be either plus or minus 1, plus or minus 3 because of this number right here, or it could also be those numbers divided by factors of 4. So plus or minus 1/2, or 3 over 2, plus or minus 1/4, or 3 over 4. 1 and 3 are easiest to check. So you can do 1 and then use synthetic division here. Because I'm checking a positive 1, I'm just having a 1 right there. If I had a factor I was dividing by, like this would be the factor x minus 1. So 4, 12, negative 1, and 2. So that's not going to be it. Looking at these, it's either going to be a positive 3 or negative 3. So I'm going to try positive 3 first. Another way of doing this is to look at your calculator and see where they intersect. Yeah, 3 isn't going to work. Let's try negative 3. So since 3 didn't work, I can mark off the factors with x minus 3 in them. So that's just that one. So then I'm trying negative 3. So negative 3 does work, so I know it's got to be a, b, or d. And my resulting polynomial is 4x squared minus 4x plus 1. So I'm looking for numbers that, because I have this 4 out here, I've got to multiply it. 4 times 1 is 4, and add to give us negative 4. That's going to be a negative 2 and a negative 2. And because I have this number out here, I've got to divide these by 4, reduce if possible. So that's negative 1/2 and negative 1/2. So that's going to be 2x minus 1 is going to be that factor. And I'm going to square it because I have 2 of those. So I've got x plus 3, and then I've got a 2x minus 1 squared because I have that same factor twice. So that's going to be d. A radical expression is shown below. Which of the following represents an equivalent expression? Okay, so I'm taking the cubed root of negative 54, x to the 5th, y to the 10th, z to the 7th, divided by y to the negative 2, and z. So I'm going to simplify this a little bit right off the bat. So I'll have negative 54 still underneath, and then I can subtract my exponents. So I have x to the 5th. 10 minus the negative 2 is the same as 10 plus 2, so that's going to be y to the 12th. 7 minus 1 is 6. And this is a cubed root. From there, I'm looking, okay, well, 54. 54 is 6 and times 9. 6 is 2 times 3. 9 is 3 times 3. Because this is a cubed root, I need to have 3 of a factor to be able to move that outside. And I have 3 3s. So I'm going to have a 3 out front. It is a negative, and it's an odd root, so I can take that negative 3 out. And so inside, I'm still going to have a 2. I have x to the 5th, and I'm taking the cubed root of it. So that means that I have 5 x's, and they have to be in a set of 3 to come out. So I'll have one set of x's that can come out, and I have 2 that are left inside. Then I have y to the 12th. Now, 12 is divisible by 3. 12 divided by 3 is 4, so I just have y to the 4th. 6 is also divisible by 3, so 6 divided by 3 is 2, so I have z squared. So I have negative 3x, y to the 4th, z squared, and then inside the cubed root I still have a 2 and an x squared. And so that is v. Number 4, a polynomial expression of degree 4 is shown. Which of the following represents a correct factorization of the expression? So looking at my 4 terms, it's not grouping again. So I can look at my multiples of 25 to find my real roots. So my factors of 25, so I'm looking at 1, 5, and 25, and those can all be positive or negative. So with synthetic division, I'm going to start off with 1. I have 1. I don't have an x cubed, so I have to put a placeholder of 0 right there. Then I have a negative 1, a 10, and a negative 25. So that's 1, 1, 1, 1, 0, 1, 0, 10, 10, negative 15. 1 doesn't work. Try negative 1. Since 1 doesn't work, this factor has an x minus 1. I can immediately mark that off. I don't have any others that have. You know what? I'm going to show you an easier way of doing this. If you'll get your calculator and you go to y equals and type this in, we're going to see if it has any zeros. This method will work. It's a little bit more time consuming. So x to the 4th minus x squared plus 10x minus 25. And I want to just go to zoom 6, just a normal window. Alright, so I just have two different places that it can cross. Okay, and I can see real quick that this is close to 2 and negative 3, and this has 4 different places that it's going to cross, so that's not going to be an option. So I'm left between x squared minus x plus 5 and x squared plus x minus 5 and a plus 5. You can do long division with these factors and see. You can also type these two examples into y2 and y3 and see which one of them graphs over it. So I'm going to type in x squared minus x plus 5 and x squared plus x minus 5 and see if that gives me the same thing. Now, I didn't see anything graph, which means it either graphed it right on top or it's off my screen. So I'm going to go to my table and see if they match up. And looking at my table, I see that every y1 and y2 matches. So when I plug this in y1, this in y2, they were the exact same, which means that this is factored correctly. An expression involving complex number is shown below. Which expression represents a simplified complex number? So you would just multiply this out. So 6i times 9 over 2. Well, 6 times 9 is 54, divided by 2 is 27. So I'd have 27i minus 6i times I is 6i squared. Then negative 4 times 3/4 is a negative 3. Negative 4 times 5i is a negative 20i. Now, negative 6i squared, I know that I squared is negative 1. So negative I squared has to equal positive 1. And positive 1 times 6 is 6. So this right here is the same as 6. So I can combine 6 and negative 3 to give me 3. 27i minus 20i is 7i. So I have 3 plus 7i. Number 6, a polynomial function of degree 4 is shown. Use algebraic methods to determine the complete linear factorization of the function. So again, easiest way to do this is on your calculator. So you're going to clear these out and type in 4x to the 4th minus 8x cubed minus 5x squared plus 18x minus 9. We may be able to narrow it down based on the zero. So it looks like it went through 1.5 right there. You can find that exactly by going second calc, looking for the zero, go to the left of it, hit enter, the right of it, hit enter, enter one more time, and that tells you at negative 1.5. So if negative 1.5 is a solution, then x plus 1.5 would be a factor. Now because your factors don't normally have fractions, you want to get rid of this 1.5. So I'd multiply this by 2. So I need to have a factor of 2x plus 3. So any of mine over here that don't have 2x plus 3, I'm going to mark them out. So I can immediately mark out B. Now I want to see a little bit closer what's going on right here. So I'm going to go to Window, and I want to see between 0 and 5, and I want to see closer, so I'm going to go from negative 5 to 5. Alright, so it looks like it touches at 1 and then it crosses right there about 1.5. So I want to make sure that that touches at 1 so I can look at my table and see, okay, at 1 it does have a 0. And I know that's a double root, that factor is going to be squared because it touches and doesn't cross. So I'm going to have an x minus 1 squared, and then my other factor is right here, and I want to find that by going left bound, enter, right bound, enter, enter again, and that is another 1.5. But this one has to be x minus that, so x minus 1.5 or 2x minus 3. So my over here that has these options, 2x plus 3, 2x minus 3, and an x minus 1 squared is C. A polynomial expression of degree 3 is shown below. Which algebraic expression represents a complete factorization of the polynomial? Okay, so 54 and 128 are both divisible by, hold on. They are both even, so they can both be divided by 2. So that'd be a 2 out front, 27a cubed minus 64b cubed. So this is a difference, because I'm subtracting, of cubes. So my difference of cubes is a cubed minus b cubed is equal to a minus b, a squared, opposite sign, so plus ab, and then plus b squared. Here my a value, the number cubed that gives me this, is 3a. And my b value here is going to be number cubed that gives me 64 is 4 and 4b. So I'm going to have a 2 out front, then I'm going to have 3a minus 4b. And this is on the front board whenever you're taking your test. It is also on your formula sheets. 3a squared. Well, 3a times 3a is 9a squared. Plus 3a times 4b is 12ab. And 4b squared. 4b times itself is 16b squared. Which is this guy down here. If you've got any more questions, need help reviewing, please let me know.